Bismillahirrahmanirrahim. Assalamu alaikum.
वालेकुम अस्सलाम सर।
वालेकुम सलाम सर।
वालेकुम अस्सलाम सर।
वालेकुम अस्सलाम व रहमतुल्लाहि व बरकातुहू।
Hello.
यस सर।
जी जी सर जी। सर आ रही है आवाज आपकी।
वालेकुम सलाम।
Assalamu alaikum. Can you hear me?
जी जी सर आ रही है आवाज।
जी जी
Assalamu alaikum. Can you hear me?
यस सर ऑफ कोर्स।
यस सर जी जी सर यस सर।
Hello, gentlemen. I am on. Can you hear me?
यस सर।
सर आ रही है
आ
आवाज।
गई थी
सर
आवाज।
आप सर हम आपको साफ तौर पर सुन सकते हैं।
I can't hear you. Anybody speaking?
सर आ रही है आवाज।
Gentlemen, can you see me? Can you hear me? Please tell.
Yes sir.
I can't hear you. Anybody speaking?
यस सर यस सर।
Hello, 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 hello. Testing. Hello. Anybody hearing me?
Yes sir.
Please respond. Please
Yes, sir.
respond. Please speak.
यस सर।
Please
Yes,
check.
sir.
I don't
Yes,
know.
sir.
You can hear me or not.
जी
Yes,
सर।
sir.
हेलो
Yes sir, I hear you.
हेलो हेलो।
अरे सौंदे पे सर जी शुरू करो।
Hello, hello, hello. Please see the chat. Please respond. Okay, now you can hear me. My voice sound is not coming, although I have unmuted you. You can speak also. So, okay, I'm going to mute everybody. So I'll continue my lecture.
Sure, sir.
So, dear gentlemen and a single lady, Assalamu alaikum. So,
Walaikum salam.
today we will continue lecture on psychrometry. And that is a PowerPoint presentation in front of you. So in this presentation, this is a very interesting presentation. This is practical practical application of psychrometrics. Psychrometrics is a very useful tool for air conditioning calculation. Without it, you cannot do nothing. Hello. So, in this presentation, I will cover review of the psychrometric processes which yesterday I have done, defining state points, how to show a state point on psychrometric chart. Then mixed air condition is one of the most interesting application of calculating psychrometric chart using psychrometric chart. This is what we do is in air conditioning we need calculation of temperature and humidity or any other condition and enthalpy of entering air to the air conditioner. That is called as mixed air. Now, then we will define also in this lecture sensible heat ratio, which we defined yesterday. It is the ratio of the sensible heat, because of sensible heat is the heat transfer because of delta T only, temperature difference only, and humidity has no role in it, only sensible part. So this ratio is the ratio of the sensible heat divided by total heat. Total heat comprises of two types of heat, sensible heat and latent heat. Now, application of sensible heat ratio is how to draw the line of cooling and dehumidification process of air conditioner. Now, then we will define supply airflow. So, with the help of this psychrometric calculations, we can define calculate supply airflow rate also. So, in this lecture, we will cover all these things, and at the end, a real world example exercise will be done for using this, for using the psychrometric chart. Now, so yesterday I've shown you this also. In this screen, this is Train company's psychrometric chart, and it is in IP system, inch pound system, which is the name of British system of units. And in industry, in air conditioning industry, you can see, you will see that you will need to know about inch pound system also. People are still habitual of using this old system because data is available to old people in old system. That's why they prefer old system, it is British system. So by seeing this presentation, you will understand FPS system also. Now here, dry bulb temperature, humidity ratio, dry bulb temperature, humidity ratio. So it is a table. It is a table of two properties, dry bulb temperature and humidity ratio. That is DBT and W, humidity ratio. So temperature is given Fahrenheit, humidity ratio is given in pounds, in grains, in IP system, grains per pound. So what we want to show in this presentation is how to draw saturation curve line on psychrometric chart. How psychrometric chart was created? It is because of this property. So these properties, these are properties of saturation taken from saturation steam table. So if we draw it on humidity versus dry bulb temperature, you will see this type of curve, exponential curve, which is shown on the psychrometric chart on the left side. By joining these points, you will get 100%, phi is equal to 100% line on this chart, and it is already done for you. So this is the science behind it. It is nothing but graphical presentation of saturation table properties like this. So after this, all other lines are drawn on this psychrometric chart: 90% relative humidity, 80%, 70%, and up to 10%, and up to 0. Horizontal line on this table, so they show 0% relative humidity, and this outermost red line is 100% relative humidity. So this is how it is drawn. Now you can see wet bulb temperature lines are like this. This is wet bulb temperature line, and dry bulb temperature line are vertical, wet bulb are slanted, and this curve is relative humidity line, and this black horizontal line is the humidity ratio line. So this is the state. So this point is called a state. Any point on this diagram is called a state of the moist air. So what we can do is, let me see waiting room. There are more admissions are needed. Okay. Now on this, you can see that on this circle, this point, this is actually a point. This shows the state. This state can be pinpointed on this diagram by only two of the properties, any two: wet bulb and dry bulb, wet bulb and humidity ratio, wet bulb and dew point, dry bulb and dew point, and wet bulb, dry bulb and relative humidity, any two properties. So this black line shows how to find dew point from this chart. This is the state. Go horizontally to left and touch this outermost line, that is 100% relative humidity, and read below it over here, or here also they are given. These temperatures are given here also, and you will find dew point. Now, how to find enthalpy? Follow this. So this point is passing through this wet bulb line. Go to the left along this line, and when it touches the saturation line, this is the outermost line. Here you will read enthalpy. Relative humidity, this line, this blue line, blue curve is passing through this point. So read what is the relative humidity. So this is how we use this diagram. Now here is shown one process. For example, we have state point is here. This is the state point, and from state point it shows that 13.5 is the cubic feet per pound of dry air specific volume. So if you go horizontally towards left, towards right, so its humidity is constant, and specific volume lines increase towards this 13.5, 14, 14.5. So the specific volume increases. So by increasing the temperature, specific volume increases by increasing the temperature. Now this is heating process shown. This yellow point on the screen shows, so this yellow point on the screen shows the state point, and this purple line towards right shows the heating process from 80 degree Fahrenheit temperature towards 85 and 90. We follow to right, so you can see how this process goes. This is heating process only heating, sensible heating, without addition of moisture. To the left, from this state point to the left, will show sensible cooling. If you remove heat from the air without removing moisture, then it will be this line, horizontal left side, moving towards left. So this is cooling only, or sensible cooling. Now vertical line upward from this yellow dot, which is the state point, shows humidification. We do not heat, no heat is added or removed from the air. Temperature, you can see at the bottom, temperature is constant. It is vertical line. So that means dry bulb temperature is constant. Without changing dry bulb temperature, go up vertically up. This will show you humidification process. Now next is downward process. From this point, yellow point, go downward. So this means W. This is the W, humidity. This is humidity ratio in terms of British system, grains per pound. And it is decreasing downward, but temperature is same, around between 78, something like that. So this is less than 80 degrees Fahrenheit, but it is constant. So dry bulb temperature is constant, but humidity is decreasing. This is dehumidification only without changing temperature. Now all four lines are shown combined together, vertically up humidification, vertically down from the state point dehumidification, and towards right heating only, sensible heating, towards left cooling only or sensible cooling. Now on this slide you can see that 50% relative humidity line passing near this state point, and temperature, dry bulb temperature is 95 degrees Fahrenheit. You can see on the diagram. And if you read, this is wet bulb temperature line, constant wet bulb temperature line goes to left, and here you can read 78 degrees Fahrenheit. It is the wet bulb temperature. So dry bulb temperature of this state is 95 degrees Fahrenheit, but its wet bulb temperature is 78 degrees Fahrenheit. Relative humidity is 50%, and humidity ratio W is around 120 grains per pound. This is how you can read the state. Now, this is the situation where we need to calculate. So this is application of the psychrometric chart, real world application. This is the damper of return air, recirculated air or return air coming point A. This is point B where outdoor air is coming. This is the duct. Inside the duct is a regulator which is called damper. So this damper can be controlled to control the flow rate. After entering here, this is called mixing box. In the mixing box, they mix both return air from the room which is cold and the humidified outdoor air which is hot and humidified. So these both here mix air. So they are in very, outdoor air is always taken not more than 20%, 25%. So when it is mixed with 70 or 75, 80 or 75% of return air, we get state C. So this is called C. This C is mixing point, and this mixture goes onto the coil. This shown, this blue, this box, this one blue box. This is shown as coil. Small, this two circular shown representation of coil pipes. There are many pipes like this, a bundle of pipes over here. That is why it's called as coil. So on this coil, C is entering. That's why it is called an on coil condition. C is mixing condition or on coil condition. Let me admit, all latecomers are very lazy. They are time suckers. They suck my time. They suck their own time. They disturb everybody. They are not desired. I'm warning them each time.
सर जी लड़के कुछ
Now,
लेक्चर
how
देना
to show
चाहते
this
हैं
process?
तो
Point A, we should mention first point, locate state A. State A is the room air. This is the room air. Room air is 80 degree Fahrenheit shown here, and wet bulb temperature is known, so we can locate this point. Similarly, outdoor air condition, wet because of wet bulb temperature and dry bulb temperature known, so we can locate this. By joining A and B, we find this process line, mixing process line. So mixing process point C will lie somewhere on this line AB. A is greater, quantity of A, return is more, so it will lie near this, depending on how much is, what is the ratio of indoor air and outdoor air. Now again coming to this diagram. So A is mixing this return air at point A. Quantities are, this is real life example, real world example, and you can see that 3000 CFM. CFM का मतलब होता है cubic feet per minute. It is the rate of flow. It is volume flow rate of the air. 1000 CFM is outdoor air. 3000 CFM is return air. That means ratio of outdoor air and return air is 1 to 3. 1 to 1 to 3. एक हिस्सा जो है ना outdoor air है by volume and 3 हिस्से return air. So इसकी ratio निकालेंगे तो 1000 divided by total air. So 1000 CFM is outdoor air divided by total. Total air is 3000 plus 1000. So we divide it 1000 with 4000, so it becomes 0.25. This is how we calculate the, we can find, because of this ratio, we can find location of point C. So from here we know that outdoor air is 25% of return air. That is a different ratio. Outdoor air is 25%, of total, that is 4,000. So 4,000 is 25% of the total. 1,000 is 25% of the total 4,000. So that is why outdoor air is 25%, return air is remaining, that is 75%. So now we know the ratio of outdoor air and return air in the mixture. So now we will calculate what should be the mixture temperature. By weighted average, we can find if return air temperature is 95 degrees Fahrenheit and its ratio, volume ratio is 0.25. So we multiply it with 0.25 and we get 23.75 degrees Fahrenheit. It is the temperature in Fahrenheit of outdoor air. Now we know that 75% is outdoor air. So we multiply outdoor air temperature, return air temperature at 80 degrees Fahrenheit at 0.75. So it becomes 60. Now by adding these two, we get 83.75 degree temperature, which is point C, and this is the temperature, dry bulb temperature of the mixed air. So now we can locate, because of these two temperatures, we can locate point C. You can see that it is near A, but far from C, because this part is 1, this is 3 parts. By dividing line AB, this is 1 in 4 parts. 1 part is here, 3 parts are here. So graphically also we can do divide this in 4 equal parts and take 1 part from here. Otherwise, calculate this temperature because of weighted average, and you can calculate point C condition. Now here is the situation shown. I don't like this window. I don't know how to remove this window. So this is permanently disturbing me because of new entries, and it is not removable. This warning will come again and again. Now supply air is given to the room. This is the situation in the room. This is 3D view of the room, and with colored flow. This blue colored arrows show how cold air coming from the air conditioner, which is called supply air. This is after after cooling and dehumidification in the coil. Point C enters into coil, and this point B gets out of the coil. So this is supply air. So return air is taken from the room. So supply air, return air, it again goes to the machine. So this is coming from the supply air is coming from the machine, and this orange line, the red line, it is return air going again to the machine. Inside the room, this yellow arrow shows heat is being added. Sensible heat is being added to the air because of presence of people and lights and equipment inside the room. And this purple line shows latent heat addition because of moisture activity, because of outdoor air, moisture addition over there, because of perspiration of the people and any water activity inside. Now, how to calculate sensible heat ratio? I have told you. So sensible heat ratio is the ratio of sensible heat gain divided by sensible heat gain plus latent heat gain. And now in this diagram you can see how to locate index point. It is already printed on the psychrometric charts. All psychrometric charts have printed a circle at this point, and in this particular chart it is 78 degrees Fahrenheit dry bulb and 65 degrees wet bulb. This is located. This helps how to draw sensible heat ratio line. These digits are show the sensible heat ratio formula we have given just now by knowing in the problem what is the quantity of sensible heat and what is the quantity of total heat. From here you can calculate this ratio. If this ratio may be 0.7, 0.6, 0.5, 0.8, whatever. So this point will be connected with this reference point. This is also called reference point, index point or reference point. So in SI system, this is 25 degree or 24 degrees centigrade in some charts. In Ashray chart, it is 25 degrees centigrade and relative MP is 50%. So this is already printed over there. If it is not printed, you can do it by yourself. Now this point is connected to 0.8. Now a real life problem, if calculated sensible heat ratio is 0.8, this 0.89 point dash will be connected here, this reference circle or index point, and extended up to the saturated line. This is saturated line. So this point, it shows you here also and at the bottom also. remember on this line, this is saturated, 100% saturated air, and on this line, dew point, dry bulb temperature, dew point, and wet bulb temperature, they all coincide here. So this is 55. This is actually dew point, and this is actually the surface temperature of the coil, and this is the. We assume that 100% contact of air comes in the surface, fully coil surface, and it gets equal temperature. Temperature of coil is equal to temperature of leaving air. So this is 55. So now this point will be called D in the next diagram. That is the surface temperature. Actually, this surface temperature in air conditioning, this 55 is called apparatus dew point. This is apparent. This is not actual temperature of the supplier. This is apparent temperature of the surface, which should be. If we have this surface temperature, only then it can meet this load ratio line. This is also called as load ratio line. Now, this was the line passing through the sensible heat ratio, 0.6. Now this is another problem. Here, 0.6 is given as the sensible heat ratio in the problem, and by joining the reference point or index point, we draw this blue line. So this parallel to this line, we will draw this line. If B is given, C is given, you can find out D. So B is room. B is C is the supplier condition, and B is the room air condition. So and D will be supplier. So it is not. It is actually drawn parallel to this line. This blue line, green line is drawn parallel to line C, B, D. This is line parallel to this line because we know sensible heat ratio. We follow sensible heat ratio. So 55 is the apparatus dew point, and actual supplier temperature may be C. Any other point, this may show position on the way to the room. So this is the room temperature or conditioned space temperature D. Actual process of cooling and dehumidification in the coil takes place like this, these black lines, because you know that so these lines are drawn on the basis of one principle, very famous principle called as straight line law. So in psychrometry, follow straight line law. All processes take place. We know only initial condition, final condition by joining initial and final condition. For example, point B and C by joining and extending this straight line. So that's why all other this is our assumption that process follows this straight line law. So that is good for calculation because we are not interested how actual process goes on. We are interested only in entering conditions and leaving conditions of the air in any device, any apparatus. So actually happens like this. Air first at constant humidity ratio gets cooled. So this is outer air, and towards left it is so sensibly cooling. Then condensation starts because of low temperature. Now temperature is such that now dew point is come. So because of dew point, moisture is condensed from the air, and its temperature is also cooled. Further coming closer to the coil, further passing through the coil. Coil is a bundle of pipes. Initially it is hotter, then it gets cooled, and at this point, dehumidification. Curve goes down, dehumidification also starts, and at the end reaches to the saturation line. So every line is drawn like this, and this is called actual process line. Nobody can draw actual warning. Okay, no, time is running short, so we are finishing inshallah. Very sensible heat ratio calculated. Another problem. This will be given 80,000 BTUs and 100,000 BTUs per hour. So in, this is sensible heat to total heat ratio, and this is 0.8. From here, room conditions are given 78 degrees Fahrenheit temperature and 50 degree humidity. Outdoor conditions given 95 dB and 68 degrees wet bulb. And ventilation is 25% outdoor air. With the help of this, we can calculate this process. We can draw this process on psychrometric diagram. Point A, point B, point C. This has been discussed already. Point A joined with reference point, and reference point extended to point B. This is supplier. Actual process take place CD. But nobody can predict this. Actually, it is just shown to you for theoretical purpose. what we know is we join D directly with C, such that process takes place like this. So from D to A, this is load ratio because sensible heat ratio is 0.8. So by joining D and A, we know this is the process taking place in the room. This is process taking place on the coil in the machine, and this blue line DA from C to D is process in the machine, cooling and dehumidification. From D to A, again sensible heating and humidification process in the room. It takes sensible heat, it takes latent heat on it, and we reach to room condition. In this way, we maintain a room condition at point A constant. Now, another application of this is how to calculate supplier flow rate. Now, how to calculate supply air flow rate? So this is formula written in front of you. Sensible heat gain divided by 1.085 multiplied by room dB minus supply dB. But remember, this is not SI system of unit. This is only inch pound system. This decimal, this 1.08 factor is a constant, and it is only for this system, not for others. The result is in CFM, cubic feet per minute. In chapter 4, when we will calculate supply air flow rate, it will be in meter cube per second or kg per second, and this formula will change. It will not. This factor will not be required there. 1.08 factor. You will have different factors. Now this is the whole combination of the today's lecture. So point A, B, C, D drawn here, and point A, B, C, D shown in the actual machine. So A is the return air in the room air. B is the outdoor air. It mixes. C is the on-coil condition, mixing block condition. This is the coil. This is the fan. Fan supplies supplier SCET at point B. So I think this is the end of presentation. Thank you very much, and time is also over.